Okay, so before we start the session, any queries or questions or doubts from the previous session? Anything that you'd like to ask me before we begin? Yes. Yesterday we had tried out a few things with delegates. We tried out firstly events, that was something new to you, and then we had tried out async code with delegates. So hopefully no problems while trying this. So let's continue further. The next major topic that we would be looking at would be language integrated query or link. Okay. Now, before we get into link, there are certain language features that are used in link that you need to understand. Okay. So initially, we're going to be looking at these language features which are mainly used in link. The major reason where they are used is in link. The first thing that we're going to try out here is something called as implicit variables. Now, normally when you create a variable, you create it this way. You would do something like this: int a equal to 100, right? In which you are specifying what is the data type of the variable. So you're saying that a, for example, is of type integer. But instead of defining a variable in this manner explicitly, you can also define a variable in this manner implicitly. In an implicit variable, you declare the variable of type var. So I would say var variable name equal to value. And I'm not giving a data type out here. I'm not specifying a data type out here. But the data type for this variable is being implicitly picked up from the value that you're assigning to it. So if I assign to it a value of 100 in this example, 100 being an integer, the variable a is also being created as an integer, right? So if you put a mouse pointer on a, what does it show to you here as? A is of type integer, right? Now, while creating the variable, you can give it any value that you want it to. For example, you can do var b equal to, and in this case, I'm creating it a variable of type string. So what is b being taken up as? B in this case being picked up as a string in this case. But once you have assigned it an initial value, you cannot change this data type. So I can't do this. B is equal to 10. I can't do this here, because B has been assigned as a string right now. So if you look at this, this is actually taken it as a string. So I can't do this. I could have done this initially itself. I could have given it a value of 10 initially itself. And what would it take it as in this case? If I give it a 10, be an integer. So that is okay. But if I've made it a string, I can't change its value later. Right? So it's not that you're creating a variable of type object or something that take any value. You're creating a specific type of variable, which means a statement like this would result in an error if I try doing only this var b. I don't give it a value. Now in this case, what's going to happen? If I said var b, it doesn't know what type of variable to create. So this is a syntax error. I'm not allowed to do something like this. Are we clear on this, everybody? Okay. Now, given these two syntaxes, wherein you could create a variable either as int a equal to 100 or you could create it as var a equal to 100. Which one would you prefer to use? What is your sort of take on this? Would you prefer line number 14 or would you prefer line number 15? Yes, inputs from you all. Very light ones.
Line number
14.
10.
Line number 15.
Depending on conditions.
Depending. Can you be a little louder, please?
Depending on conditions. If
So
we
what is the
want,
condition? You want to create an integer. What would you prefer?
if we explicitly want a to be integer only, then we will mention line number 14.
Now, I'm telling you that you want to create an integer. So what would you prefer? Would you prefer 14 or 15?
14.
So 15.
14.
All right. Now my take on this is that both of these are okay. There's nothing right or wrong in both of these. But the problem in line number 15 is it's not very readable. Now, unless you know for sure what it is, you are not clear on this. Like for example, what if I wanted to create a long variable which has a value of 100? Now this is not creating a long, it's creating an int. Or what if I wanted a short? You're not getting a short out. If I had to create a long, I would have had to use a syntax like this. Okay. And if I had to typecast it to get what I want, why not then directly given what I want on the left hand side in any case? So first thing is readability. This is definitely clearer as to what you're creating. There's no ambiguity out here. First thing is readability. Second thing is, if you know what to create, then why go in for var? Okay. So my suggestion to you is you use an explicit variable wherever possible. So then why would we need an implicit variable? In what situations would you need to create an implicit variable? You would need to create an implicit variable where you don't know what type of value you are going to store in it. Quite often, the right hand side will return a value that you don't know the type of. Right hand side that you're getting in here you know it's 100, but it might be giving you in more complex code. It might be returning a value whose data type you don't know. Now, in such situations, var would be the best option. If you don't know what to create, then create a var. But if you knew explicitly what to create, my suggestion would be, I prefer, and this is my way of looking at it, if you know what it is, then create specifically that itself. Okay. So in what situations would you not know the data type out here? We'll come across these in later situations, but mainly in link. Mainly in link. At the beginning of the lecture, I told you that these language features that we're going to look at are mainly used in link. So the why answer to the question, I mean, I've asked you always that whenever you're writing any code, the first thing you have to write yourself is, why am I doing this? Why am I doing it this way? And in today's session, the answer to your why is always going to be in link. It is like this. So in link, you will need to do this. If you haven't seen link as yet, but when we do try out link, that is where something like this would be useful. Right? Okay. Few other things out here. It can only be used for local variables. You cannot use it for class level variables or as a parameter to a function or as a return type from a function. So var can only be used in local variables. Are we clear on this? Look at line number 26. What am I doing on line number 26?
So reading the type of where a
So if you remember get type is a method of the object class, right? Everybody has a get type method. So I'm trying to print the type, the data type of A. I've declared it as var. So what do you think would be the answer here? What will it return? What will be the data type for A? Yes.
int.
Sir.
So if you move your mouse pointer on that, it actually even tells you that it's an int. But when you use get type, it does not return int, it returns the CTS type. So what is the CTS type for an int?
In 32.
In 32.
Right? So system.int32, that is what it is actually. All right. So I just wanted to show you that that's an int being created. Easy way of knowing it is, of course, to move your mouse pointer on that. Okay. So that's the first thing that we have tried out here, which is creating implicit variables. Anywhere else that you will have seen the var? That you'll have seen the var?
JavaScript.
No, here in .NET. I'm not talking about that. I'm talking about .NET. Anywhere else that you'll have seen the var? Notice the var. Very good answer. When you write a for each loop, shows you var item in collection. And I have been, consciously making you do what? I'm saying don't use var. If your collection is of type integers, then change that var to int. I've been making you do that. Right? But yes, good observation that this is where else that var is actually shown here. So you're saying whatever your collection, I don't know the name type of collection, I will use var in this case. This is what they're saying. But wherever possible, if you know the type, use that type. All right. Let's move on to the next concept. The next thing that we're going to try out here is an anonymous type. So first thing is, what is a type? Type is another name for what? In .NET, type is what? Another name for what?
Class.
For a class. Correct, class. Now that is actually oversimplifying things. A type can be one of the 5 possible basic types. There are 5 basic types in .NET. So you can either have it as a class or an interface or a delegate or a struct or an enum. These are the 5 types in .NET. These are the 5 basic types in .NET. 5 types being what? Class, interface, delegate, struct, or enum. So all of these are referred to as a type. Okay. But for your easier understanding, you can think of a type as a class, like similar to a class. So if I'm saying that I'm going to create an anonymous type, what do you think I'm creating here? When I'm saying an anonymous type, what am I creating?
Anonymous class.
What does the word anonymous mean? Explain the word anonymous.
No name.
Class without name.
A class that does not have a name. One second. So an anonymous type is basically a class that does not have a name. Now, normally when you are creating an object of any class, what would you normally do? You would say class 1. And what is class 1 here in this case? Just the name of the class. O is equal to new class 1. This is what you would normally do, right? Now, if I didn't know the name of the class, if I didn't know the name of the class, how am I going to write down that code in that case? So what I could do here is I could use var. If you don't know the name of the class, what can you use out here? Var could be used in situations where you don't know what you're creating. So I could say var o is equal to new. And since the name of the class is not going to be there, I leave that blank. And I could do this. What is this now? What am I giving here? What is this a sign of?
Body.
No. Specific term that we use. Remember when we did this?
Object.
Object what? Half of
The
word.
scope of object class. Initializer.
Object initializer.
Initializers. So this is an example of object initializers where I could specify what A is equal to 10, let's say, and B is equal to whatever, 20 maybe, or whatever, X. Right? So I could write my code like this. I could have done this as well right here in the earlier example. I could have done this. So here in this example, what am I knocking off? What am I not giving? What am I not giving here?
Name.
Name of the class. So an anonymous class, the code for creating an anonymous class would be like this. You create an anonymous class while you're creating an object of the class at the same time. So what is O now? What is O now? O is a reference of an anonymous class, right? And new of this, the right hand side, is an object of that anonymous class which has properties A and B. The anonymous class that I'm creating here has properties A and B. What is the data type for A?
Int, sir.
Int. And the data type for B is a
String.
string. So my anonymous class has two properties. This one, this in this example, has two properties, A and B, of type int and string. Are we clear on this? So what you see here is how you create an anonymous type. Okay. First question, of course, that you have to ask yourself is, why would you want to do this? And today I'm not going to talk a lot. I'm in a lot of agony, pain, whatever. So my answer to you is going to be a very short answer. If you ask me a why, my answer is going to be one word answer. What would my answer be? Yes.
Link.
You need this in link. Right? You need this in link. So I have sort of insulated myself against your why question. Every time you ask me a why, I'm going to give you a straight answer, which is, in link, you'll need this concept. All right. So let's try this. Let's try creating an anonymous type. Okay, again, I'm going to copy paste from my existing code. So look at line numbers 38 and 39. I'm creating an anonymous type on those lines. That is similar to if I had line number 36, which obviously I don't have line 36, but that's what would have been the syntax if you have to create a class of type class 1. Instead of class 1 type, we're creating an anonymous type out here. Properties here are A, B, and C of specific types like integer, string, and Boolean values. Right? Okay. What am I doing on line 40? What am I doing on line 40?
Retrieving B.
Printing obj.b, which would give you this value. And what am I trying to do on line 41 and 42? 41 and 42, what am I doing?
Reading the data type of, type of objects.
Giving you the name of that class. The get type is giving you the name of the class, details about that class. So we said it's an anonymous type, and then let's see what type of name it generates. So we'll come to running the code in a moment. But if I did obj dot, what would I get to see? Obj dot, what would I get to see?
A, B,
A, all properties.
All properties ABC, and of course the
object methods.
object methods, those would be there in any case. All right. Okay, so let's try running this code and focus on the last two lines. The B value is okay, but focus on the last two lines. Let's make this main and run this code. So you have the value of B, but see what is the name of the class that it created. It's generating some default name like F underscore underscore anonymous type 0 backquote 3, and then the parameters that it's using out there. Right. Now you will notice that the name of both OBJ and OBJ2, the name for both of them, they were using the same class. You see the two lines, they both are identical right now. So both of them are generating the same class. Why are they generating the same class? Why are they generating the same class? It's not generating two classes, it's generating only one class.
Sir, they are reference of same class.
Yeah, but why? Why is the compiler generating only one class and why not two? They're two different objects.
Properties are same.
Properties are same with context of data type.
Correct. So the names of the properties and the data type of the properties are the same. Therefore, the compiler will generate only one class for you. Right? But if these had different properties, let's say, for example, in the second case, I have not given C. I'm not given C. So now what is happening now? The properties for both are different. And now if I try running this, see the name of the class getting generated, you'll find that this is anonymous type 0 and anonymous type 1. So there are two different classes being generated out here for you. Right? Now, where are these classes getting generated? These classes are generated in the assembly itself. So behind the scenes, in the assembly, these anonymous types would actually be generated. How do you go behind the scenes? How do you see the IL for this? How do you see the IL for this? What utility do you need to use?
So ILDASM.
Correct. Have you all used it at least once without me telling you to do it? Hopefully you have. So every time you learn a new concept and I say behind the scene, this is what is happening. Automatically your inquisitiveness should take you to the IL and see what is happening. So look at the IL and see how it's generating it in for an anonymous type. Right? All right. If you move your mouse pointer on where OBJ out here, see what OBJ shows you as. What OBJ shows you as. OBJ is of type what? It says whatever, single quote A. Right? OBJ is of type single quote A. And this is an anonymous type. So A is what? No, tilde A. That's just some name they are giving to it. Is new, int A, string B, bool C. This is your anonymous type. Just some random name they're giving to him. It's like, if you're walking on a road and you see somebody whom you don't know and you want to call out to that person, How will you call out to that person? Now, let's say he's dropped his whatever, let's say hanky, or let's say his wallet he's dropped, and he's walking away. How will you call out to that person and draw his attention to you?
Array.
Gir gaya hai tera, whatever. There you can talk in Hindi, Marathi, that's okay. Right. So that's precisely what they're saying here. Is A, some just random name. A is what? A new int string bool C. All right. So that's your anonymous type. Okay. Let's move on to another language feature that we want to discuss. We're going to look at partial classes. Okay, partial classes. So let me show you first the way in which they are used, and then I'll discuss where these are required. So if you look at these two classes, both the classes have the same name, class 1. Both of them are called class 1. But I have also given it as a partial class 1. Now what happens here is when you declare a class as a partial class, you can actually write multiple such classes. You can break up your class into multiple such classes. Right? So each one is a part of that class. And the compiler simply combines all these classes together and gives you a single class. So if I create an object of class 1 now, and if I said O dot, what is the compiler simply going to do? It's going to combine these classes together. And O dot would now give me what? What would I see when I say O dot?
I and J.
I and J. So that one class can be written in different parts, and not just 2 parts. You can have as many parts as you want. Right? Multiple parts, 2, 3, 4, as many as you want out here. Are we clear on this, everybody? So let's check this out. If you look at O dot, you'll find that you have I and J, and of course the object class methods. Okay. While creating a partial class, there are a few things that you need to keep in mind. First thing is they need to be in the same assembly. Another word for assembly. Another word for assembly in Visual Studio.
Project.
So they need to be in the same assembly or in the same project. They also need to be in the same namespace. So you can't have them in different namespaces. They need to be in the same namespace. And of course, the other thing was that they need to have the same name. All right. Okay, so let's try creating one more partial class. Here, see what I'm doing out here. I've given the same namespace name. Here. Okay. And if I create one more partial class here, it's in the same project, same namespace, same class name. And let's call this K, for example. So would I also get K now? Look at this. Namespace,
No.
language features 5, class 1, language features 5, same namespace, same class name, same project. Would I also get K in there? I, J, and K? Yes? Quicker answers, please. Yes?
Yes.
Yes? O dot? I
No.
dot. Why not? Same project, same namespace, same class name, everything satisfied. So why no? Right? So you could do this as well. right? Okay. Let's try adding another file in the same project. See this, right click and add another class, right? So I've added into different this thing, same namespace, again, same name, L, right? I've defined it here. I go back here. Would I get O dot L also?
Yes.
Yes.
All right. So O dot L. What if this was not having the same namespace name?
K will not be.
K will not be available
It
to
would not work. So would it be an error? Would it be an error?
No.
no.
So now IJK, the K is not there. L is there, of course. What happened to this class now? Now this is a separate class. It's creating a separate class in the namespace language features. So now there are two classes being created. There's also a language features.class one being created. So prerequisite, of course, was we said that it needs to be in the same namespace, and that would work. Okay. So what are we seeing here? We have seen a situation where instead of writing the code for a class all at one place, you can split it into smaller parts, into each of them being a partial part of the class. In what situation can we use this? When would we require this? I'll give you a couple of examples. First example where you could use this is if you're working in a project, if you've got multiple developers working on the same class at the same time, right? So let's assume Kaustubh and Arvind and Sakshi and Dishi are all working on the same class at the same time. So what can they do? They can all of them create a partial class, right? Kaustubh writes his methods, Arvind writes his methods, Sakshi writes her methods, and Dishi writes her methods. Each of them are writing it separately. What will the compiler simply do? It will simply combine all of them and put them together into one class. So that could be one situation where multiple developers are working on the same class at the same time. So each one of you all create a partial class. The second situation, you all have actually seen this yesterday or seen this earlier, the second situation. All right, I'll take you back into that WinForms project that I used to explain, event handling, right? So this is a WinForms example. Let's say I drag and drop a button. Now when I drag and drop a button, I showed you yesterday that Visual Studio generates some code for you. You remember that? So when I drag and drop a button, Visual Studio is behind the scenes is doing what? Creating an object of the button class, right? So similarly, if I create other controls, whatever other controls I create, Visual Studio is actually generating code for that. Now, what if I go and write my own code? Like for example, what if I go into the button click and I write some code out here, whatever, let's say, message box dot show, whatever, hello, for example. So I have written my own code out here, and Visual Studio also has generated some code. Now you will notice that the code that I'm writing is being written where? Is being written where?
Partial class.
In a partial class. And if you open the code that Visual Studio is generating, this is also being written in a partial class. Both of them are in the same namespace. So what will the compiler simply do? It will combine the two codes. So look at the code that was there. Visual Studio generated this code for me, and then this code, a lot more it generates, of course, a lot more code it generates. So this is the code that Visual Studio generated. And this was the code that I wrote right now. And all it does is merges the two codes. Okay. So this situation will happen often. Quite often, Visual Studio will be generating some code for you. And you will be writing your own code. So the code that Visual Studio generates is in a different file in the same project in a different partial class. Your code in a different file in a partial class again. Okay. So this situation also you'll face multiple times. Are we clear on this, everybody? All right. Questions, if any? Okay. So I'll go back to my code that I was using. The
So-
next, yes.
So maybe I wasn't paying attention, but the first time you created the next same namespace as language features 5, so you showed us that K was being showed in the object, but then the next time you created so class 1 in the different file, and then the K was not showing. Why was it so?
No, right, it was showing. It was showing.
Achha, okay, so it was below, like it was.
If I change the name of the
Okay.
namespace, it will not show.
Okay, so L came before K, that's why K was shifted down, and that's why it wasn't showing. So wasn't as in IntelliSense, मतलब what
No, it
it
showed
wasn't
that.
showing in
It
box.
showed that.
Yeah,
It showed
got
that.
it. Got it.
The problem was that what I showed you was not when it was not showing is if you gave it a different namespace. That is what I did. I changed the namespace.
Okay, got it.
So I was trying to show you that as long as it's in the same namespace, there's no problem. But if you change the namespace, then it's not available. Okay, the next topic that we're going to look at here is partial methods. Now, let me explain to you what are partial methods before we get into the code aspect of it. Let's assume you're writing your own class. Okay, class 1, whatever. And let's say this is what you're writing, public void do something. Right. Now, while writing down this code for your class, this is your code, right? Whatever code that you're writing, you want to keep a placeholder in the code. Okay. You want to keep a placeholder in the code. So what is this word placeholder? What does this mean? When you say you're using a placeholder, what does that mean? Okay, I'll give you an example of a placeholder and see whether you understand that. Let's assume that, we were in physical class. We are not, but let's assume that we were in physical class. So during the lunch break, at the end of the session, you would have a lunch break. During the lunch break, you go and, sit at a particular location and you want your friend to sit next to you. Right? But your friend has not yet come. So what do you do to indicate that, this spot, my friend is going to come and sit out here? What do you do?
Reserved.
How do you reserve it?
Keep our bags.
Using handkerchief.
Whatever, handkerchief, bag, book, maybe your tiffin box, something you place out there. So whatever you're placing there, you're actually using a placeholder to indicate that this place can be filled by someone else later. So when your friend comes, what do? You remove that, whatever. Let's say you're keeping a bag out there, you remove the bag and the friend sits there. But that indicates to the others that that place is being kept for someone else who's going to come in later. So that's a placeholder. Similarly, here in your code, you want to say that I want to keep a placeholder for some code that will be written by someone else at a later point of time. Right? So what is this placeholder? I'm saying that somebody else, right, will be writing some code and I want to keep some reserved place for this. Now, how do you keep the placeholder in your code? To do that, you have to declare a partial method. Okay, this is not the syntax. I'm just explaining to you how it works. This is what you do. You would create a partial method, and here you will call that partial method. You will call that partial method. This is what you would be doing. Okay. So this partial method becomes your placeholder. Okay. Now, a partial method can only be given in a partial class. You can't give a partial method outside a partial class. You have to give it inside a partial class. Right? Now, two situations could exist. Two possibilities could exist. The first possibility is nobody else comes and writes any further code instead of your placeholder. That is the first possibility. Nobody else writes it. So you have kept some place for somebody, but your friend, let's say, has not come today. All right, or let's say is delayed and nobody comes out here. So if nobody is writing any code out here, if no code has been mentioned here, then while compiling this code, the compiler removes the partial method and the call to the partial method. So first possibility is what? If nothing has been written, the compiler simply removes all that code. First possibility. The second possibility is what? Second possibility is what? Somebody is coming in, writing the code. Now, how would that somebody else means what? Somebody from your team, maybe from your project team, for example. So somebody else will come and do what? Create a partial class again. Sorry, I wrote partial in the wrong place. This should have been partial class. So, right? Somebody else comes and writes this class. And somebody else writes down the code for the method. Right? Whatever the code for the method, somebody else comes and writes down this code. Now the method exists. So the compiler will then retain that code. So it will make a call to that method. So that's how this partial method works. And the partial method is simply a placeholder in your code. Are we clear on this, everybody? Questions, if any, at this point of time about what is a partial method?
Sir, the code should be defined in the partial method or in the place of placeholder.
Nobody will come and touch your code. This is your code. This is your partial class. Nobody will come and make changes here. What will they do? They will create another partial class and write down the code for the method.
Okay.
Sir, so does this mean that if somebody doesn't write the code, that whatever code we have written will not execute?
Correct. It will be removed.
Okay.
Compiler will remove all traces of the partial method.
Okay. So, and what did you mean by placeholder in the code? As in, like, how is it going to call it?
Placeholder in the code means that this is where the code will be called.
Acha, as in the code which will be written in future, that will be called here.
Here, correct.
Okay. Okay.
So basically what you're doing is, in your code, you're giving places. You're giving places where others in future can come and insert code. You're just giving them an option. Ki, theek hai, if you want, you can insert code here. By doing what? By writing a partial method.
So when we are writing a partial class, anybody can implement it further. Then what is the actual need of placeholder? That that person could have written public partial C1 and written the method on his own.
So what you're saying is why, but the call to the method would not happen. Na? What code you are writing, the partial method could have been written, but how will you call that method? So calling that method also is the placeholder. This is what is happening.
Okay, sir.
Sir, it's like abstract method.
No, abstract method must be written. Must be written.
Yes,
right?
sir.
Must be implemented. Here, this is optional. If you're asking me syntax wise, does it look like an abstract method here? The similarity is that here also you will not be giving a code body. So there, if you're saying that is that similar to an abstract method, that similarity is there. Syntax similarity is there, slight. What is the syntax similarity?
Yes,
if that is what you meant, that you will not
Yes,
write the
sir.
initial code, then yes, then you are correct. But if you're asking me, does it work like an abstract method? I mean, the obvious difference is abstract method must be implemented. This need not be. Okay. So on one point, yes, I would accept what you're saying. All right. Are we clear on this, everybody? Now, where is this use? Before we go into the syntax also, where is this use? Very often, Visual Studio will generate a lot of code for you. Most of the code for you will be generated by Visual Studio. And if you have to customize this code, Visual Studio will leave a lot of placeholders in the code. So what are the placeholders meant for? Places where you can go and write your own code. And how will they do that? They'll do that with the help of partial methods. So what would you be expected to do? You would be expected to come and write down this class, this other class, and given a partial method of your own, if you want to put in code there. So without going and changing any of the code that Visual Studio is generating, Visual Studio is giving you features where they're saying, okay, here, if you want to insert code here, go and write down the partial method. That is where it is majorly used. And this feature is used a lot in something called as link to SQL. So if we are going to look at an example of link to SQL will require you to understand what is the partial method, and which is why we are actually looking at this. Okay. Let's try out a small example. All right. So can I ask you to look at this code? What do I have here? Firstly, a partial class in which I've given a partial method. So line number 109, that's my partial method called validate. Okay. This is my code. This is not a partial method. 110 is not a partial method. It's a fully implemented method. In this, what am I doing? What am I doing here in this?
Calling validate.
Yeah, calling validate, calling the partial method. At this point, the code has not been written down. When I'm writing this class, the code has not been written down. So let's assume this code was not there. Okay. Let's assume this code was not there. So this is what I've written out here. This is the class that I've written. Achha, right now, what will my check method return? What will my check method return right now?
False.
Right? Whatever I have initialized this to is true. So right now my check method is going to return true. Right now I'm saying I don't have any validations on this method. But in future, if somebody wants to add validations in my code, what would they need to do? They would need to write code in this validate method. Right? And then they can set is valid to true or false in that validate method. Right now is valid is true, but they can write code and validate and then change the value of is valid to either true or false based on what code they're running. At this point, without writing the further method, if I go and call o.check from my main, what will this return? This will right now return true. And when I run this code, what will the compiler do? I'm more interested in knowing that. What will the compiler do?
Eliminate that calling line.
Correct. The compiler will remove all traces of your partial method. Why? Why?
It is not
Why?
implemented.
It is not implemented. Let's check this. Let's check this. So I'll go to the ILDASM. And day 8, language features, bin, debug, language features.exe. So look at the code that it will generate. Okay, by the way, before we go into partial methods, do you see these? What are these?
Types.
Types
classes.
that was generated. Okay, so anyway, that's besides the point. I want to actually show you the code for this. So look at partial methods or class 1 code. You'll notice that it does not have the validate method. The validate method has been removed entirely. Not just here, if you go into the code for check, and if you see this code, nowhere is it calling validate. My check code calls validate, but in this check code, in the IL for this check code, that validate, there's no reference to it at all. So the compiler has simply removed all references of this one. Okay. Now let's go back and write down this partial class where in future somebody else, for example, is doing what now? What are they doing? They're actually writing down the validation code. And they'll perform some validation code out here and then set is valid to either true or false. They'll do that in their code. Are we clear on this, everybody? All right. Now, when they do that, now what would happen now in this case? If I try calling this is valid would now return
False.
false. Let's run this once. And then it returns false. And I am actually more interested in showing you what is happening in the ILDASM. So if you go back and open that, partial methods thing, look at this. First thing is validate has now come in. First thing, it has included validate, which was not there before. Second thing is in check. Now it is making a call to validate. So that's how the compiler works. Are we clear on this, everybody? So that's how you'd use a partial method, mainly used by Visual Studio to provide placeholders in its code for you to complete the code later. Okay, that is the scenario where it is used most often. Any questions, any doubts before we move away from partial methods?
Hello, sir.
Yes.
Like when somebody write the code for that partial method in future, then how will he come to know the name of method? By IntelliJ?
You see it's going to be written in the same project. It's
Okay.
going to be written in the same project.
Yeah. Yes, got it.
It's going to be written by your same team members. See, remember partial methods. Okay, I didn't show you this. Good, you asked me the question. I didn't show you this. Partial methods must be defined within a partial class. Again, partial class we have said needs to be where in the same project, in the same namespace, must have the same name, right? So those things are true for a partial class. Those things are true here also. Then partial methods must return void. Return type of a partial method will always be void. They can be either static or non-static. They cannot have out parameters, and partial methods are always implicitly private. Meaning what? I can't go and give it an access specifier. Okay, they're implicitly private. I can't explicitly go and give in any access specifier here. All right. So coming back to your question, remember that they have to be given in the same project. Partial method will have to be written in another class, which is a partial class, which is in the same project, same namespace also.
Yeah. Yes, sir. Got it.
All right, let's move away from partial methods. And the next concept that we're going to look at is extension methods. Okay. Now, when extension methods was first introduced, okay, when extension methods were first introduced, they blew my mind away. They literally blew my mind away. Right? I'll tell you why. I'll tell you first what you can do with an extension method, and then we'll discuss what they are. So supposing supposing you said string s is equal to whatever. Right? Sorry. Supposing you said string s is equal to whatever. And if you did s dot, what would you see? What would you see?
So methods of string class.
Methods of the string class. Similarly, any other data type, even if you take an int, for example, int a, right? And if you did a dot, what will you see? Methods that are available for every int, correct? Or if you, for that matter, if you took your own class, you created your own class, class 1 obj is equal to new class 1, and you did obj dot, what will you get to see? Methods that are available for your class, defined at your class. Now, what if I told you that you can write an extension method for any existing type? Type means what? Type covers everything. Type could mean what? Class, interface, delegate, struct, enum. So what if I told you you can write an extension method for an existing type? Which means effectively what I'm trying to say is, supposing I write this my method here. Supposing I write this my method here. Okay. This my method here, and let's say my method is an extension method for a string, would be available if I did s dot. What if I told you that? And I can add that anywhere that I want. Any existing type, you name the type and I can add it out there. So I can insert my extension methods to this existing types. Right? This is what I can do with an extension method. When I first heard about it, my fundas were shaken. The fundas were like, oh, we talked about encapsulation and we talked about how if you define your class, nobody can go and change your class. You can, create your data, you can do data hiding, you can have methods that accept your data and whatnot. And now what are we talking about here? Anybody else can write a method and that method would be available through an object of my class. Somebody else who I don't know is adding methods in my object. I thought it was insane. I mean, my core object-oriented fundas were shaken. I felt that, oh my God, I'll have to learn object-oriented coding all over again. Whatever I had done is all now, see, when I learn, I mean, even when you all learn, if you know one thing, then you build on that. You say, okay, earlier it happened like this. Now, this is what is slightly different. But when this happens, it's earth-shattering because whatever you learned now suddenly seems, oh my God, now what's going to happen? That was my reaction to the extension. My first reaction. See, when something like this is announced, first they say that we're going to come out with it. And then a few, maybe months later, they come out with it, and then in the beta copies, and you can try it out and whatnot. So this was my initial reaction. Was I justified in my initial reaction or not? You think I was right in thinking that? Because I mean, this is insane, absolutely insane. How can somebody possibly go and write a new method now for an existing class without even having the code of the class? I'm writing it for a string. Can you imagine? I'm saying s dot. I'm writing a method for a string class. So that was my initial reaction. Then I started using extension methods. I tried, coding extension methods. I tried, reading up on it and trying it out. And when I started trying it out, my instant reaction was, Acha. Oh, this is what extension methods are. And I realized that there were two major culprits who had completely fooled me. There were two people, two entities responsible for completely making an entire donkey out of me. The first one was Visual Studio, and the second one was the compiler. Together, these two crooks made me believe that something wow was happening when it was actually something acha. This is what it is. All right. So let's see what these extension methods do. How you can create an extension methods for practically anything that you want, and how can it, what exactly is happening behind the scenes. So let's start with scratch. All right. Okay. So the first thing that I'm going to do here is to create an extension method. I want to create an extension method for a string length or for an int, whatever I want, I can create. Okay. Now to create an extension method for any class or for any type, let's use the word type rather than class. First step is create a static class. That's the first step. Help me create a static class. Yes. Public static class, and then whatever name doesn't matter. So this is what I've done. I'm creating a static class. First step. Any class name doesn't matter. What can a static class only have?
Static method.
Static members.
Static method. The second step is create a static method in the class. Right? Create a static method in the class. So this is my extension method that I'm creating. Right? It needs to be a static method, but few things you need to keep track of. The first parameter should be the type for which you are writing the extension method. Okay. What do I mean by that? Supposing I want to write an extension method for a string. Okay, then the first parameter should be what?
String.
String. Supposing I want to write an extension method for an integer, the first parameter should be integer. Supposing you're creating a class 1, and you want to write an extension method for that class, the first parameter should be of type class 1. That is the first thing. Second thing is precede the first parameter with this keyword. Don't just give in that as the parameter name, also give in what? This keyword. And that's how you can write an extension method. Help me with what I said. I want to write an extension method, my favorite method, let's say display. I want to write that down for a string. Help me. Carry on.
Public static display.
Right, return type.
String. Sorry, void.
Void, let's say. Okay. You can, you can have it whatever you want. So string display. And what should I take as the parameter here now? First parameter should be of type
String.
String.
This string.
Right, and precede it with this keyword. So this string, whatever is. Right. Okay, what do I want to do in this? Let's say in here, what you want to do now is up to you. What that method does is your baby. I'm showing you how to write one method. And console.writeLine string, whatever s. Right?
Sir, is it like equals method in string?
No. All right. So this is what I've done out here. That's it. Done. You have created your first extension method. Via me, of course. You have still not created it. You will do it in the lab. But this is what you have expected to do. So the moment I've done this now, check this out. Check this out. When I say s dot, you will find that display is now shown to me. Display is now shown to me. Right? Now, how do I know it's an extension method visually? Just by looking at it. Can you see anything different?
Yes, sir. Extension in bracket.
Down arrow.
Down arrow.
First thing you have to look is the left hand side. Look at the symbol. So the extension method is shown with the down arrow. And yes, on the right hand side, it shows you the word extension. But visually, even without going to that method, visually, you should be able to identify what it is. So that's it. S.display. If I run this now, this would work. What will it show me now? S.display, what will it show me? The value that I have in the string would be shown. Are we clear on this? So ABC being shown out here. Clear? That easy. Okay. Help me write an extension method for an integer. All right. I'm going to ask you to do two methods. First one is simple. First one, I just want to do, just like I did display, I want to do i.show. What will i.show do? It should display the value of I. So it's very simple what I'm asking. That's the first one. The second one I want to do here is this, is I is equal to I.add 5. So what am I doing here in this method? What am I expecting you to do in this?
Add 5 to I.
Add 5 to I and return that value. Okay, return that value here. So help me with the first one, show. That's really simple. Come on. What will you do out here? Call it out for show. Call out the code.
Public static
Carry on.
void show
Carry on.
this int I and
Perfect.
code.
Perfect. Absolutely. It's very similar to what we did here. The only difference here is instead of this string S, this becomes this int whatever. And instead of display, you could call it as show. Are we clear on this? You want to call it I, you call it I. That doesn't matter. So this is the first easy one. All right. Now, if you notice in here, when you say s.display, the variable s is coming down as the first parameter. When you call s.display, this s is coming here as the first parameter. Similarly, if you call i.show, it's called i.show, and i.show will also work. Right? I.show, what is happening here now in this case? I is coming down here as the first parameter to the extension method. Okay. So in that case, how do I write I.add 5, which takes a parameter? Where will this go now?
In parentheses.
Yes, but what would be how many parameters would add have when you write an extension method?
2.
Would be 2, because the first parameter will be the the variable with which you're calling it. And then the first parameter here is actually now the second parameter in the function now. So help me write that. Help me write that. Public static.
Int
Yes. Return type here now changes to an int.
Add
add
this.
Carry on.
this
Int I.
This int I. This is what this is the I dot. This is the first parameter. And the second parameter here, which is a value that you're accepting here, will be what?
int
Int j, for example.
J.
Whatever you want to call it. And now what?
return I plus j.
I plus J.
I plus j. So this is what we're doing out. All right. So if you understand this, then you're sorted. That the first parameter here in this function is actually the second parameter. Correct? Why? Because the first parameter of the function is reserved for how you're calling it. That is what it's reserved for. And this would also work. Let's first do the add and then call show. So this should show me what now? I was initially 10 and this should now become 50. Let's run this. Okay, and that's what you're done. Right? Good, easy. Fine. So this is the, when a magician shows you a trick, he's showing you this hand. He's showing you this hand. So your attention is all on this hand, but he's actually doing it with the other hand. He's doing something with the other hand. So it's like a distraction method. So these two crooks, Visual Studio and the compiler, are also doing something similar. You think it is so good. But let's try and understand what is happening out here. What is this actually? This is an extension method. Is what is a static method in a static class. Have you ever seen a static method in a static class before this? Yes or no? Have you seen one before this? static method in a static class? Have you created one? Yes or no? No answers.
Yes, sir.
You all need to put in a little more energy today. I need your help. Today I'm suffering. So you all need to have that little excess. You all are going back reverse. If I had to call a static method in a static class, what would you do to call this? Let's say if you had to call display, what would you do to call display? Yes.
Class name.
Class name.
Class dot display.
My extension class method class dot display. And of course, let me first put in this. So my extension method class dot display. And what does this take as a parameter? What does this take as a parameter? String S. So I just pass S out. So this is nothing new to you, no? This is something that we've been doing all along. Yes or no? Agree?
Yes, sir.
Yes, sir.
All right. And if I run this code, you get that, S is displayed, it's calling that code. It's working the way you want it to. So why did I call Visual Studio a crook? Why did I call Visual Studio a crook? And why did I call the compiler a crook? Because when I write this line of code, the compiler changes it to this line of code. So my s.display is internally converted by the compiler to what? My extension method class.display of s. That's the compiler fooling me. Secondly, why am I blaming Visual Studio also? When I say s dot, Visual Studio shows me all the extension methods, making me believe that I've written a method for that. But it's not that. So Visual Studio is the first accomplice who's making you believe that you've written something nice. And the compiler is the other crook in this. Unnecessarily, they scared me. Made me believe, oh my God, so many different things I'll have to learn now. How can I put a method for a class? When all that they are saying is, okay, this is an alternate syntax for calling this method. Are we clear on this? Questions, if any? Okay, quickly call I. Help me call these other methods from I. Quickly. How do I call that add?
Class name dot
My
show.
extension method dot show.
Sorry, my extension method dot add, and this takes what? I, comma 5 out here, and then store it back into I. I is equal to so and so. So this is what you're doing in the first case, and helping call show. So instead of display, now you call show and pass I as a tab. Same code that we did earlier is what I'm doing out here. Are we clear on this, everybody? Questions, if any? All right. I'm going to take you one step further. And I'm saying that if I write an extension method for a base class, it is also available to all your derived classes. An extension method written for a base class is also available to where?
Derived class.
Derived classes. So if I write an extension method for object, object happens to be the base class of whom? Object is base for whom?
For all classes.
Of all classes.
All classes, either directly or indirectly. Where all will this method be available? Where all will this method be available? Yes.
For all classes.
All different classes.
For everybody. So if I did s dot, you'll find that this extension method for the base class is available here also. Are we clear on this, everybody? So that's what I wanted to point out here. So if you write an extension method for a base class, and you had a derived class which inherits from base class. So if you write an extension method here, then what is happening here? Extension method also available here. Are we clear on this? Easy? All right. Let's take this further. Let's take this further. Supposing you have a situation like this, where a class is implementing an interface. Where a class is implementing an interface. If you write an extension method for an interface, it is also available for all classes that implement that interface. Extension methods written for an interface are also available for all classes that implement that interface. Are we clear on this, everybody? So let's have a look at this concept. We have seen this, right? We've seen this in the previous example. Let's try this. Okay. So I'm going to take you through some of my existing code and copy paste that. Before we do that, let me put in a comment out here. Okay. Look at this. What is this right now? What is math operations? An interface
Interface with abstract.
which has two methods. I create a class that implements that interface. So what does class CLS maths have now? It has both these methods now implemented, add and multiply. Both of them I have written down. Okay. So if you create an object of CLS maths, what is it going to create right now? O dot will show you what right now? Add and multiply. Correct? Okay. Now I'm going to go and write an extension method for an interface. Okay. I'm going to write an extension method for an interface. If I write an extension method for iMath operations, it will also be available for what? For CLS maths, because CLS maths is implementing iMath operations. Right? So how do I write an extension method of the interface? The first parameter is the interface. First parameter is interface preceded by this. What is this? That's how you're writing an extension method. So this interface name. And what about these parameters? What are these now? These are the parameters to the function itself. So my extension method is called subtract. This is the method of IMath operations, and the subtract method has A and B as parameters, and we are doing the difficult task of returning A minus B. Right? So that's what we're doing out here. Are we clear on this, everybody? All right. So now, as a result of this, if I create an object of CLS Maths object will have not just add and multiply, it will also contain subtract. And what will it also contain? What will it also contain? Extension method for base class. Why would it contain this one? Why would object of CLS Maths contain this method also?
So you have written it for object type.
Right, an object is the base class. So let's try this out. So what I want to do here is this. What I want to do here is this. Create an object of type CLS Maths. And if I did O dot, you get your add, multiply, extension method for the base class, and subtract, which is the extension method for the interface. All of these are available. Are we clear on this, everybody? So I'm interested in showing you subtract at this point. Questions, if any? Right? If I run it, of course, it gives me the output here, but that's not what I'm interested in showing you. Wanted to show you this concept out here. Any questions?
So can you scroll down?
Do you have a question, or just you wanted to see the code?
Sir, I wanted to check because we have not declared that method inside interface, subtract method. But
Correct.
it is getting called using the object of
because if you look at O dot subtract, what is this? Look at the symbol. It is not part of that interface, but it is a extension method for the interface.
So we don't need to declare it inside interface.
No. We are defining it as an extension method. What is an extension method? Additional methods that you're creating, which can be called this.
Okay, so but the extension method should be inside a static class.
They are, no? This is where I created my.
But this extension method is of an interface, right?
Yes.
So how they are correlated? Because the
you're just saying you're writing an extension method for a string. You're writing an extension method for an object class. You're writing an extension method for a IMath operations interface. This is what it means. Okay, this is what it means.
Okay, sir.
So what can I pass to this? What can I pass to IMath operations? What can IMath operations receive?
The object of derived class.
Object of any class that implements this interface.
Yes, sir.
That is what I'm doing. That is what is happening here. So when you did O dot subtract, O is being passed here. So for this object, this is the code that you're writing.
Yes, sir.
Okay. Now, these last two concepts, what are we talking about? About writing an extension method for a base class or writing an extension method for an interface. These two concepts are used extensively in LINQ. All of your LINQ code is using this concept. See, LINQ can be written, I mean, I'm going a little ahead of myself. LINQ can be expressed in one of two forms. It can be expressed as an expression or it can be expressed as a function. And all your LINQ functions are extension methods, which are written for either one of the base classes or written for one of the interfaces. So I'll go back to what I said at the beginning. These concepts, all these concepts that we're covering today, from morning that we started, all the concepts are extensively used in LINQ. To understand LINQ, you need to understand the concept. You may not necessarily use this concept anywhere else, but in LINQ, it will definitely be used. All right. So there'll be a little more clarity once you try out these examples in the lab. And I want this clarity before you try out the LINQ examples. If you understand these, then LINQ becomes easy to understand. All right. Are we clear on this, everybody?
Yes, sir.
So,
Yes.
so usually when we implement an interface, only those methods which are default are available to the class, right? Like we don't have to override them. So as such, if this method is available, does it mean that internally it converts it to default and then it is available in the implementing class?
You. I told you.
Okay.
These two are two big crooks. Extension methods is the biggest scam that has been run on. Making you believe that it is doing so much. Internally, it's a static method in a static class, which we learned on day 2.
Yes.
So don't break your head too much on it. All right. It is the biggest scam that has been carried out by .NET. When they announce this, oh, we're coming out of the extension methods, this is happening, that is happening. Everybody is excited. And then it comes out, and then later they tell you, Acha, this is actually this. All right. Which brings us to the hero of the piece. Language integrated query or LINQ. Okay. All that what we are struggling for so far has been for LINQ, which is basically language integrated query. Okay. So what are we doing in LINQ? What exactly is this supposed to do? As the name suggests, it is basically querying something, writing some queries, querying some data, right? And the language integrated part of it implies that the syntax that you will use will depend on the language that you're coding in. So if you're coding in C#, you will use C# syntaxes. If you're coding in VB.NET, you will use VB.NET syntaxes. So this is entirely dependent on the language that you're coding in, and which makes it easier to learn compared to some of the other options that you have. So let's try and understand what you could be querying. You could have as your data, right? If you had data, one possibility is you could be, using something like collections or arrays. All right. Your data could be in the form of collections or arrays. What is common in collections and arrays? Any guesses, or anyone who knows the answer? What is common in collections and arrays? What is the common feature? If you look at an array, right? If you look at an array, right? What is common in collections and arrays? What are arrays?
They can hold objects of same type.
Array, look at the screen.
So yeah, they are
Derive from
Implemented
enumerables.
They are
interfaces.
implementing
Implementing the I mean the classes.
single parent.
Okay. Do I need to say more?
No, sir.
They're implementing I collection. They're implementing I list, I enumerable, and of course few other interfaces. But essentially, all arrays are also what? Collections.
Collection.
Agree or no? All your collection classes also implement I collection. So, which is why I'm saying what? Which is what I'm saying what? Collections are arrays. Now we give them two different names, but they're actually what? They're actually collections only. Okay. In case of arrays, you don't have that feature of the flexible adding elements out there and whatnot. Those are not implemented. But otherwise, it's similar to that. Those features are not exposed to you. Okay. Coming back to this. So you had what? You had one possibility is your data could be in the form of collections or arrays. Second possibility, now you're not seeing these, you would have probably heard of this, or you might have been mentioned by me before or whatever. You could possibly be having data as what is known as a data set. Okay, I don't know whether you remember, but on day one, I actually had said system.data.data set. I had just mentioned it in passing. I had not explained it. But you have a concept called as a data set, and which, as the name suggests, can also hold your data. So if some of you have been reading extra stuff or whatever, you may have come across this a data set. When you're working with databases specifically, you may need to work with data sets. Other place where your data could be held could be in XML format. So you could have data in XML format and you're actually manipulating this. You might have data in a database actually. Right? You might have data in a database. And I'm not adding, but I'm not writing that here, but you could have something called as the entity framework in .NET. And your data could be part of your entity framework. Entity framework is an ORM tool. So if you've worked with Hibernate, right, you would have an idea about what the entity framework would be. It's an ORM tool. So data could be in that format also. But these are the four sort of major places where data could be held. Now, if you were to write code for working with this, right? If you were to write code, what code would you need to write if you were to write code out? So code to manipulate I collection, for example. That code you'll have to write. If you have to work with data set, you will have to use system.data.data set methods. If you have to work with XML, then there is a namespace for system.xml. which you will need to manipulate. And if you have to work with databases, then you need to know SQL to manipulate your databases, and then be able to call that SQL from your code out here. So to call that SQL, you will need to use ADO.NET. In .NET, there's something called as ADO.NET, which allows you to manipulate your databases. So to do one task, what is the one task that you're trying to do? You're trying to manipulate data. To do that one task, you have had to now, so far, learn different syntaxes. So the syntaxes for I collection would be totally different from dataset, would be totally different from system.xml, will be totally different from SQL and ADO.NET. So essentially you're doing the same thing, but you are having to learn different methods of doing exactly the same. Now, what does language integrated query do for you? What does link or language integrated query do for you? It says that to manipulate these, right? To manipulate these, yeah, you don't need to learn different syntaxes. You don't need to learn this. You won't need to learn this. Instead, to manipulate all of this, you can do so with the help of link. And link will allow you to do what? Will allow you to manipulate all of these. Okay. So what would be the advantage of something like this? What will be the advantage of something like this? Yes. One.
So we can fetch data from database and use it in our code and manipulate it.
I'm saying that the code that you're writing for all of them will be similar.
Okay, so there will be a standard between all the languages.
Correct. So there will be a standard syntax that you will use to manipulate your data. You all should actually appreciate this the most. In the last 4 or 5 months, you all have been tortured with different languages, different packages, different database types, maybe, I don't know. And you have had to learn a new syntax every time. So what if, I mean, that then Link doesn't do that, but what if you had to learn only one way of doing everything? Wouldn't that be so much easier? So in .NET, it does this. In .NET, it says that rather than having to learn different syntaxes for doing, different operations, you can write similar, syntactically similar queries in Link. All right, and manipulate different sources of data. That's what Link is doing for me. Are we clear on this, everybody? Now, we haven't yet been exposed to these other options, but we have been exposed to working with collections or arrays, right? So the examples that I'm going to take up in here are mainly targeted towards the first option, working with collections and arrays. And as we see the other options, we can then see how Link could be used out there. When you use Link to collections on arrays, right? This is referred to as link to objects, right? When you work with data sets, it is called link to data set. No prizes for guessing the next one. Next one will be called what? Link to XML. And the last one here, typically when you're working with a SQL Server database, it's called link to SQL. Right? So the query that you write will be similar in all of this, but the way you set up your query, there will be small changes in each of these. So before you, I mean, it's not going to be identical code. Let me be very clear about that. But the way in which you manipulate that data, the code for that will be similar. So I would say 95% of the code that you write in all of this will be similar. 95%. There'll be a 5% change for initially, setting up the things out there. But once those things are set up and standardized, 95% of the code that you'll write will be exactly the same. Right? So this is what we're going to do out here. Let me go in for a new project. Sorry. And go in for a console app still. Okay. Before I write my first link query, I want to actually set up a few things out here. So what are the things that I want to set up out here? First thing I want to do here is populate it with some dummy data. So what I have here is what? Tell me what I have here. What are these? What have I created here? Two classes for employee and department. So I'm going to actually create objects of these classes, create collections, and then work with this. If you look at the two classes, you'll notice that there is a common column between the two. So I'm going to also perform a join between the two to get values from first and the second. Okay. So these are the two classes, department and employee. Few things that I have added out here. Okay. Second thing that I've done here is in my class program. Tell me what am I done out here? What are these? What are these now?
Collection.
List.
Two collections, a list of employee and a list of departments. The list of employees is called LST employee. The list of department is called LST department. Okay. And I also have this. What is this doing for me? What is this doing for me? Yes.
So as you said,
Object initialization.
records.
Just basically populating it with some dummy data. So initially itself, there are some values which I can write queries on. So the first thing I'll do in all my code is called addRecs. So addRecs is now adding a few records for me. Okay. Now we are all set to query that. So in the first few examples that I'm taking up, I'm going to be working with LST employee out here and writing a query on this. Let's start with this. In link, I'm going to be using var mostly because I don't know what type of data I'll be getting. Right? Because I don't know what type of data I'll be getting. Therefore, the return value from there, I'm going to be keeping it as a var. So as things get more complex, you're not going to be sure about what is the return type out there. So this is a standard way of writing a link query. Let's say var EMPS is equal to, this is a it's like a select star from table name, that sort of a query. From EMP, let me write down the query first and I'll explain it. In LSTMP, select EMP, right? This is the, the first link query that we're writing. From single object in collection, select something. This is what the query is doing. So let's try and understand how this query works. First thing is, what is LSTMP? What is LSTMP?
List or
Reference of employee list.
A list of employees. It contains a list of employee objects. Correct? Now, if LST employee is your collection, is a list of employees, what you're giving here is one single object in that collection. So what does that make EMP now? If this is a list of employees, what does that make EMP now?
single object.
What is a single object? Correct. Single object, correct answer. But what is a single object now? What is the data type of EMP?
Employee.
Employee.
Of type employee. So because this was a list of employees, EMP now became an employee. Right? So this is one single object from the collection that you have. This is the collection that you're doing. Achha. Now you can select anything that you want. You can select anything that you want. What am I selecting here? What am I selecting here in this case? Select EMP. What is EMP?
Single object in list.
Yeah, the whole employee object. I'm not selecting part of it. I'm selecting the whole employee object. So this is what I'm doing. Now this code that you write, will run multiple times. One per object in your collection. So how many objects do I have in my collection?
8.
How many? 8, I think. Right? 8 objects. So this statement I'm saying will be executed 8 times. It's like a for each loop. Does this look like a for each loop? Does this look like a for each loop or no?
No.
A for each loop. Does this look like that or no?
Yes.
Yes, sir.
Right? So I'm saying this statement here would be run multiple times. One per object. One time per object. Achha, so first time it runs, you're looking at the first employee. What are we saying? Select what? Select what from that first employee?
Employee object.
Select the whole employee object. I could have selected some part of it only, but I'm saying no, select the whole employee object. And this statement is going to be repeated for all the employee objects. So for the second object also, what is it saying? Select what? The whole employee object. And I'm going to be now repeating myself multiple times. So for each object that you have here, this is what it's going to select for each object. And whatever is the output that you're getting, would be returned to my left-hand side. So my left-hand side, EMPS contains what now? What will the EMPS contain?
Objects.
Objects, yes, but be more specific. What is the data type of those objects? What will it be?
Objects of employee class.
But it's not just one object. It will be
List.
multiple employee objects. So this EMPS actually contains an I enumerable of employee objects. contains an IEnumerable of employee objects. This link query is returning an IEnumerable of something. In this case, an IEnumerable of EMP. Are we clear on this, everybody? If you remember IEnumerable of something, this was the generic version of that. And iCollection implements IEnumerable. Right? When you have an IEnumerable, what is possible? What can you write with it? What type of thing can you do with it? You can write a loop with it. You can write a for each loop with it. Are we clear on this, everybody? So if EMPS is an IEnumerable of employee, how do I show you the output? How do I display you the output? Help me display the output. What would I do to display? What is the output of this statement?
So write a for each loop.
So help me with the for each loop. For each
Employee
item in
EMS.
EMBS.
Now, if EMPS
Employee.
is an IEnumerable of employee, if EMPS is an IEnumerable of employee, what will item be?
Of employee type.
Very good. It will be one employee in there. Item will be of one employee. So if you look at item, here it is employee item. Employee item. EMPS was what? IEnumerable of employee. So can we write this as employee item? Would that also work?
Yes.
Yes. But when you're working with a link query, quite often your link query might change. And when it changes, your left-hand side might also change. So if your left-hand side changes, then one object of that may also change. And therefore, instead of giving a specific type, you generally write var out here. When you're working with link queries, because your right-hand side is going to keep changing. Not here. And as we write more queries, you will understand queries will get more complex. You may not know what it's returning. So since you're doing that, since it's getting in more and more complex, you're not knowing what it returns, the safe option here is to write var. Are we clear on this? All right. So item here is of type employee and console.writeLine. So if I said item dot, what would I get? If I said item dot, what would I get?
Properties.
Properties of the
employee.
whatever the employee class. In this case, let's say name and basic and department number and whatever else that you would like to display, you could actually display that. Okay. All right. I have gone in done an override of the toString out here. I've done an override of the toString out here. So what will this do? What is this showing me? What is this showing me? It's actually showing me the different properties out here. Okay. So can I use this? Can I use the toString out here, toString implementation, so that I can display it there? So instead of displaying it in this manner, I can simply say console.writeLine item dot toString. I could do that. And when I say item dot toString, it's going to show me this code out here. It's going to show me this code out here. In fact, when you're doing console.writeLine, you don't need to do a dot toString. When you say console.writeLine, it automatically calls a dot toString on it. So I don't even need to do a dot toString. I can directly say console.writeLine item. And let's try running this. Right? And this is what I am displaying out here. This is what my toString is returning. If you want a different output, you return that differently. Are we clear on this, everybody? Questions, if any, at this point? Right. What was your link query returning? What is the link query returning?
List of employees.
It's not a list.
Object.
It's an enumerable of something. Right? So remember this. It doesn't return a list. It returns an enumerable of something. Now, if you look at this loop, if you look at this also is like a loop itself, isn't it? What is it doing? It's looping through your items out here and selecting one item at a time and then putting it into the output. So this statement also functions similar to a loop. And for your for each loop to work, what is the prerequisite? For your for each loop to work, what is the prerequisite? Yes. For you to
So
write
the class should implement enumerable.
So it should implement enumerable. So here also, if you have to write a link query, you can write a link query on anything that is returning an enumerable of t. What can you write a link query on? Something that returns an enumerable. So if it has to implement enumerable, if it doesn't implement enumerable, you will not be able to write a link query on that. So whatever you're writing a link query on needs to have implemented enumerable of t. Are we clear on this, everybody? Any questions, any doubts on what we've done so far? We've just written one query so far. Clear on this? Okay. I had actually, started the session late. I had a morning session and I was feeling miserable in the morning. So no condition to take a session. So I took, a little bit of medicine, a little bit of hot water, gargling, this, that, whatnot. And I was in the condition to take. So that's why I requested Nisha that I'll start at 11. And I told her that I'll finish at 1 because I was not sure how long I'll take. But now that I'm feeding off your energy, now that you all are, there with me and I'm training you all and all that, I'm feeling much, much better. Maybe I should have just started off the training at 10 o'clock as usual. And I would have felt better without any medicine. So I'm in a good mood to take it till 1:30 if you all are. Right? Can I continue for half an hour more?
Yes, sir. Yes, sir.
Yes, sir.
Okay. So we have something little more substantial to work on. That's the idea. Otherwise, just one query, you're not really very clear. So hopefully I can finish some part of what I want to take before giving you all a break. So with your permission, I'm carrying for half an hour. Right? Okay.
Sorry to disturb you, sir. Sir,
Yes.
if you suggest, can we take 1 hour proper break and then continue at 2?
I have another session at 2.
Okay. All right.
Right?
No issues.
So when I'm not taking your sessions, I'm actually taking another session.
Okay.
So yeah.
I thought you will also get a 1 hour.
No, I know. I was in fact going to tell you that if I'm not well, I'll stop in between. But as I said, these guys have tremendous energy and the vibe, and I feel that. So,
Right.
So let me continue for half an hour.
Yes, sir. Sure. 1:30 we meet. Yeah.
1:30-ish.
Yes.
Okay. Yeah. So we have just written the first link query out here. Everybody. Any queries about this? Have you understood about this? Everything about this? Any queries about this link query itself? Because I'm going to now manipulate this a little bit. Yes?
Sir, can you just one time how to read that query? I mean, one more time, can you please tell it?
At one time, how to read?
Yeah, like before we have learned database, so it was like select star from EMP, and then how to.
So this is also like a select star from EMP. This is also like that. But in your database, when you say select star from so and so, somebody else is writing code which says whatever records you're getting, loop through the records and show them on the screen. Somebody else is doing that for you.
Okay.
Right?
Yes.
Now here you have to do it yourself. That is the only difference. There also it returned to you multiple records. And the output that you saw was somebody else having said that, okay, when I say select star from whatever, I will loop through the records one by one and show you what the output is. Here now, you're doing the same thing. So this for each loop will remain standard. This will not change. The way in which you're writing this will remain exactly the same. You're just going to be changing your query and then get different options out here. But you'll be returned what? What does the query return here?
IEnumerable of employee.
IEnumerable of something.
Yes.
So that will remain the same. That won't change.
Yeah. Yes, sir. Understood.
Yeah. Any other queries out here? Okay. Now, a word of caution. A word of caution. This seems similar to what?
For each loop.
No, the whole query.
Yes, SQL query.
It seems similar to that, to a SQL query. Seems similar. But the first thing you have to remember here is that you're not writing SQL. You're writing C# code. This is language integrated query. So the language, the syntaxes that you're using are not going to be SQL syntaxes, are going to be C# syntaxes. And generally, because you see similar words, like you see from, you see select, right? The tendency is to think SQL. But I'm asking you to think C# and not think SQL, right? So I'm going to ask you a few things and then you're going to help me with that code. So let's try another variation here. Okay. So I'm going to do the main one, main two, main three, that sort of a thing. Instead of saying from EMP in LSTMP, select EMP, right? Instead of saying this, I'm going to say select emp.name. I'm going to say select emp.name. So what is the change out here now? Instead of selecting the whole employee object, I'm selecting one property from there. Correct? So I'm going to ask you this question repeatedly. You're going to get bored of this question, but help me with this. What is LSTMP?
Selection, list of employees.
List of employees. What is EMP?
Single object.
Single object employee. What is emp.name?
Specific name of the
What data type? I'm asking for the data type.
Field inside object.
String.
String. So what does that make EMPS?
String.
IEnumerable of string.
Excellent answer. In the earlier case, when you said select EMP, this EMP was an employee. Therefore, EMPS was IEnumerable of employee. Because EMP was of type employee, this EMPS was of type IEnumerable of employee. But now if emp.name, if you're selecting, this is actually a string. So the return type in this would also change and this would be IEnumerable of string. Right? So now again, taking it further, supposing I did this, what is EMPS? Quicker answers, come on. EMPS was
IEnumerable of string.
So what does that make item?
String.
Makes it a string. Correct? So if I did item dot, what would I get to see? Item dot, what would I get to see?
Methods of string
Properties.
class.
Will I get to see item dot name?
No.
No.
No, sir.
So the correct answer was I will get to see all the properties and methods of string. Are we getting this, everybody?
Yes,
So
sir.
because now your query has changed, the way in which you're accessing elements here also has changed. So if you did item dot, right? These are properties of a string, properties and methods of a string. So let's reconfirm whether you gave me the right output. This was IEnumerable of string, item was a string, and that's what you got out here. So you will not get this. Clear on this, everybody? Similarly, instead of taking employee dot name, if I had taken employee dot, let's say employee number, I take an employee dot employee number. Again, quick answers. LSTMP is what? Quick.
Of employee.
LSTMP,
List of employees.
list of employees. EMP,
The object of employee.
employee. Data types I'm asking for. EMP dot employee number,
Int.
integer. EMPS,
Enumerable of int.
IEnumerable of integer. So if EMPS is IEnumerable of integer, what is item?
Integer.
Int. And what will you get with item dot? Item dot will give you what?
The
Property
method and
methods
property which
of
will call
the
on integer.
integer. Now, if you can understand this, if you have understood this, half the battle is over. Half the battle is won. You know now how the link query is working. All right. So let's try running this. We had tried it in two ways. One was, of course, with name. The second one was with employee number. Here, of course, if I'm displaying this item, here you are getting the employee number. So these are the employee numbers that you get out here. Clear on this, everybody? All right. So now, let me comment out this for a moment. Now, what I want is, I want two columns. I want my query to give me two columns. I want name as well as employee number. I don't want only a single column. So can you help me with the query? This is what we had done earlier. Can you help me with the query? I want both things. I want name and employee number both. Yes.
On EMP in IST, LST EMP, select EMP dot name, comma, EMP dot, EMP.
Very good. Very good. Excellent. Any other suggestions? Right. No other suggestions?
2 lines of code.
Only one line. I want one line. I don't want two separate things. I want one line.
Array. Array, sir, array.
Okay, so would this work? Should this work?
No, sir.
No. Array?
Yes.
Select column 1, comma column 2 from table name. So simple. Yes or no? So should work. So again, quick questions. What is the data type of LSTMP?
List of employees.
List of employees. What does that make EMP?
Employee.
Object.
Employee. So what does that make this? What is the data type for this?
Object.
Object.
It's not an object. Object doesn't have these properties.
Employee.
It's not an employee. Employee doesn't have only these two properties.
Int and string.
Int
and
String.
string. What data type are you inventing? Int and string.
No, sir.
What is your gender?
Male.
Sorry.
Where?
Hmm?
Where?
Where are you? Where cannot be given like this.
Sir, array.
It's not an array. Is it an array? It's
Key
not an array.
value. Properties.
So what if I wanted 3 columns? Then key value and another value. The answer, the hint to this of how to write this is in what we have done before link. If you have to write something like
Extension.
Generic.
this, extensions are methods. Now keep guessing one by one all the options. So we want to have something who has an int and a string in it. So we would need to create a class. We will need to create a class that has an string and a
Partial
integer.
Anonymous type.
That is the answer I'm looking for. After going through all the options, we have come to the only option that was left out, which was anonymous type. So what is an anonymous type? An anonymous type is a class that doesn't have a name. And you would be specifying properties out there. So the anonymous type is being created at the time when you're writing the code. You're not creating a separate class for it. And when you write that code, when you say new so-and-so, that's when the anonymous type is being created. And that's what we'll need here in link. So if anonymous types were not there, if C# didn't support anonymous types, then here to get these two properties, we'll have to create a class. We'll have to create a class which has these two properties. Because we can have only one type there. We can't have multiple options there. Somebody suggests int comma string or whatever. You can't have a data type which is int comma string. So you would need to create a class which has these two properties. Now imagine for every link query, if you have to create a different class, right? There will be a little, too lengthy a code that you have to first write a class and then use that class out here. So what does this give you? If you have to do this, you have to write down the code in this manner. Select new and then whatever properties that you wanted out there. And what is this new so-and-so? What is this creating for you?
Object initializer.
Yes, but what is this the syntax of? You're correct, object initializers, but new with that, what are you using?
Anonymous type. Class object.
Anonymous type.
Anonymous type.
So you're right about this, that this was your object initializer like syntax. But when you use new and so, that's how you're giving an anonymous type. So this is actually creating an anonymous type for you. And what are the properties of the anonymous type? What are the properties of the anonymous type?
Name and employee.
This anonymous type, name and employee number. Are we clear on this, everybody? So once again, continuing with the questions. LSTMP was what? Quick. Data type list of employees. That's not changing. The answers remain the same. EMP was
Object.
employee. No?
Yes,
Data
sir.
type was employee. And what is this now?
Anonymous type.
Anonymous type. So what is EMPS now? What is EMPS now?
Anonymous type.
IEnumerable of anonymous.
IEnumerable of anonymous type. IEnumerable of anonymous type. Why is that answer changing? Earlier it was first case, it was IEnumerable of employee. Then it became IEnumerable of string or IEnumerable of int. Now it is IEnumerable of anonymous type. Right? Let's see this. If you move a mouse pointer on that, IEnumerable of what? Of that A.
String and int.
That A. Remember, you have to call somebody across the road. And that anonymous type contains what? String name and int environment. So if EMPS is IEnumerable of the anonymous type, if EMPS is the IEnumerable of the anonymous type, what does that make item? What is item now?
Sir, instance of that anonymous type.
Correct. One instance of the anonymous type. And what will you get when you do item dot?
Name and EMP.
Name and EMP number.
Very good. So this is what you have to understand. If you understand this concept, as I said, link queries become very simple for you. You should know what that link query is written. If you understand that, half the battle won. Let's confirm what you're saying, whether it's correct or not. So if you did item dot, what did we get out here? Employee number and name. Right? And item itself is what? Is the anonymous type. Okay, so you will have one of three things that you will do when you're doing a select. What are the three possibilities that you will do? First possibility is what? You can select. You can select what? What can you select? First possibility that we saw.
Whole
What have you
object.
selected? The whole object. First possibility, whole object. Second possibility.
Single property from an object.
Single property from that object. Or third possibility is if you want a combination of columns, then what you need to give out here?
Anonymous type.
An anonymous type, which has all those columns that you want. So these are the three possible things that you will give in your select state. Select, option out there. These are three possible things that you can select. Either whole object or one column from that object or an anonymous type containing a combination of columns. Clear on this? All right. Let's look at the next one. So far, we have been selecting everything from there. We've been selecting everything from there. What have I introduced extra here now?
Where clause.
And that will limit which objects are included in the return value. So only objects that satisfy this condition will be included. Right? So if you look at this, I think I have this employee. Anyone else with 10,000? No, everybody else with
Second last. Arpan.
Arpan. Okay, second last. So other than Vikram and Arpan, everybody else would be included in the out. Right? Okay. I can give one of three combinations with select. Remember the three combinations with select. So I'm not changing that, but you know what to do if you want to change your query. Either whole object or single property or anonymous type with multiple, properties. So that will remain the standard thing. So other than Vikram and Arpan, I'm getting all the values out here. All right, this is what I'm giving. Right. So this is what I have out here. Okay. What if I wanted to pick up all the names which start with the letter V? What would I use then? All the names which start with the letter V.
Wildcard.
Like V.
Like.
Pattern
Now,
matching.
Like is exactly what I don't want you to think. Because what are you thinking? You're thinking SQL.
Queries.
Your brain is going into the SQL mode. But this is not SQL. What is this? This is language integrated query. So what syntax are we using out here? We are using C# syntaxes. Right? If I had to combine conditions, let's say I had to write an AND. In SQL, you write the word AND. In here, what will you use? Yes. In C#, what will you use?
Logical AND.
Correct. Double ampersand. Or if you have to use OR. In SQL, you will use OR. But in C#, what is the OR operator? The double pipe. So this is what I warned you against. When you're writing your link queries, don't think SQL. Think C#. So look at the next two queries. What is this one doing here in this case? This is an example of an AND. Right? And the string has a method called starts with. So that's what I'm actually using out here. So look out for these sort of things when you're writing your queries. Okay. That was your where. Okay, the next one, and tell me what I'm doing out here. 4. Tell me what is this one doing. Tell me what this one is doing. Line numbers 95 to 98.
So
Yes.
sorting according to
Ascending order.
Yeah. So the order by is very similar to what you learned with order by in SQL. So sorting it in ascending order. Right. So sorting by name in ascending order. If you wanted to sort it by, in a descending order, the words ASC and DASC will not work here. The full words, ascending and descending. So that's what you could give out here. So this is by name in descending order. What about this one? Look at this. Multiple columns, right? Where employee.department number in ascending order, and if the employee.department is same, then name in descending order. So different queries that you could write down here, right? Could I have also written a where in here? I have not done so, but can I also write a where in there? Yeah, so you can actually use all these queries out. Okay, I'm not writing on the output. You can try it out in the lab and see how the output would vary.
Sir, what is the output of line number 104?
10? 10?
4. Yes.
It will take, firstly, it will sort it on department numbers and where in ascending order, and wherever the department numbers are the same, then for those records, it will sort it within those records in name in descending order. So if I had to take these records, if I had to show you this, where I've got these two have the same department number. So VIKR would come in first because name in descending order. Vikas will come in second. These three are having the same department number. So it will actually be Shweta, Mona, Abhijit, right? Those would be the ways in which it will come. Clear?
Yes, sir.
All right. Let me end with this last example. Okay. Last example for the day. Let's be a little quick before 1:30. Okay. Not possible, but anyway. So what am I doing in here? What am I doing in here? Yes.
Joining to table.
Join. All right. So in the join, now first thing is let's see what it's taking. LSC department is if you remember on top, LSC department is containing what? A list of departments. Now between the two employee and departments, the common column is department number. Right? Department number is the common column between the two. So let's come back to the query. And look at this. What is LSTMP? Quick, again, answer the same questions. What is LSTMP?
List of employees.
List of employees. So what does that make EMP? What is EMP then? EMP is
Object.
one of that list. So don't say object. Don't say object. Say employee. If this is a list of employees, then this data type is employee.
One of
that, yes. So which is an employee? What is LSC department? List of departments. So what does that make DPT?
One of that department.
Which is one object, which is one department object. So look at this. This EMP was of type employee, sorry. And DPT was of type department. Right? So you got this. Now from so and so, join so and so, on, and what am I picking up here? What is this picking up here? What is this picking up here? Between
Two
the two,
common
what is
columns.
Equals
the common column between the two. The common column between the two. Wherein we are saying employee dot department number equals department dot department number. Right? So this is the common column between the two, department number. Have you understood this part of the code? Have you understood this part of the code? Yes? Now, if you understood that part of the code, the last part is the simplest. So what do you want to select? What do you want to select? So you can select columns from, or instead of saying columns, let me say properties. Properties from employee or from department as well. Now, what are the possibilities? What are the possibilities? First possibility is, I could say select EMP. What will this do for me? What will this do for me? Select what?
all employees.
Only the employee object.
Complete
Only the
employee object.
employee object values
All
or the
employee.
common values in there. That is the first possibility. Second possibility is what could I select? Instead of employee, I could select what?
department.
Department. That is the second possibility. What is the third possibility? I have the third possibility written down here, so let me uncomment this. What is the third possibility? What is the third possibility? Both employee and department objects. So if I'm selecting two things, what do I need to do? If I'm selecting two things, what do I need to do? Anonymous type. Right? That is the third possibility. Achha. Now, instead of selecting the whole employee and the whole department object, what is the other thing I could do? I could select employee dot name, comma, department dot name. So I could select specific columns from here. Specific columns from here. Are we clear on this, everything? So this is also a anonymous type. Okay. So if I use, okay, now give me the answers. Okay. Supposing I use EMPS. Supposing I use EMPS. What is EMPS? Quick answers.
Enumerable of EMP.
I am enumerable of employee.
Employee.
Of employee. So what will EMP be?
Object of employee class.
Correct. So EMP dot will give me what?
Property of that class.
Properties of employees. So all properties of employees it will give. Correct? Understood?
Yes, sir.
Okay. What about if I did this one, second one, what will EMPS 1 be?
Enumerable of
Enumerable.
department type.
Correct, correct. INumerable of department. So if EMPS 1 is INumerable of department, what will EMP be?
Object of the department type.
Correct. Object of department type. Very good. So if I now did EMP dot, what would I get?
Property
Also,
of
properties
department.
Properties of department. Excellent. Very good. Carry on. Next one. What will this return? What is EMPS 2?
Anonymous type of.
Very good. INumerable of anonymous type. And what are the properties of that anonymous type? What are the properties of that anonymous type?
Object of EMP and department class.
EMP and department objects. So look at this. Anonymous type is containing an object of employee and an object of department. So if I did now EMP dot, if this was EMPS 2, and if I did EMP dot, what would I get?
properties of
Department and employee class.
I will not get properties of employees and departments. I will get these two. I will get
And
these
then
two.
again dot.
Correct.
List of
So I will get EMP dot
department
department,
and EMP.
and EMP dot department is of type department. And I will get EMP dot EMP, which is of type employee. So whatever you're giving here is going to be available here. All right. That brings me to the last option. What will EMPS 3 contain? EMPS 3.
EMP.name department.
EMPS 3.
Enumerable. Anonymous.
INumerable of what? An anonymous type which contains name and department. So if I use EMPS 3 and if I did EMP dot, what would I get?
Properties of string.
Which is name and department. Right. So if you have understood this, then writing the link query becomes very, very simple. Which is why I've been asking. I must have asked you this question 50 times at least so far. Ask yourself the question, what is EMPS? And then what is EMP? If you get these answers, you can work with your link queries. All right. So I'll leave you with this. This is where we are stopping for today. I'm not done with link. I'm about halfway through or less than halfway through link. There are many more things I want to do in link, but we'll continue with these tomorrow. Now, why I wanted you to try these out is because the second syntax of link, there is another syntax of link, is slightly different. And if you understood this first syntax, then the second syntax becomes very easy to pick up. If you're not, then that becomes a little more complex to understand. That second syntax of link uses lambdas. So we're going to look at that in the next session. All right. We'll end here. Thank you for sitting patiently through, a really long time. And I'll see you all in the lab, hopefully.